Welcome back to Physics with Miyoshi. Today we're going to talk about Newton's laws of motion. Just give you a little introduction. And first of all, Newton discovered relationships between forces and mass back in the 17th century. And so let's talk about what force and mass are first. Force is really just a push or a pull, and and it is a vector quantity. There are two types of main forces we look at. Contact forces, which means you have to touch it. So if I exert a force on something, I have to be physically touching it to exert that force. There are also non-contact forces like gravity that act through a distance. And then mass is a scalar quantity which just tells us how much stuff there is in a body. And stuff, yes, is a technical term. The three laws that Newton had are his first law: a body in constant linear motion tends to stay in motion unless acted upon by a force. So a body that's sitting there, a body at rest tends to stay at rest, and a body in motion tends to stay in motion. And that's what it's expressed basically as if your acceleration is 0, then your velocity will stay constant, whether that velocity is 0 or some other magnitude. Newton's second law says that the net external force acting on a body results in an acceleration in the same direction as that force and inversely proportional to its mass. What that means is that if I push something with a force, and again force is just a push or a pull, but if I push something, then it will accelerate in the same direction that I'm pushing, but the bigger it is, the less acceleration I'll have, and the smaller it is, the more acceleration I'll have. So if I have a little Honda and I'm trying to push it to get it moving, that's going to be a lot easier to do than pushing a big semi with the same amount of force. Okay? So, and we can also express that as its famous F equals ma. This little sigma here in front, that just means the sum of all the forces. So when I take the net, what that means, the net external forces, means when I add up all the vectors for my forces, that net force, or that sum of my forces, is equal to my mass times my acceleration. Or the acceleration vector is equal to my the sum of all my forces divided by my mass, or by the mass I'm trying to push. Okay, and the third law. The third law is when a body exerts a force on a second body, that second body exerts an equal and opposite force on the first. That one's expressed often as our action-reaction law, and in other words, if I'm pushing on that big semi, it's also pushing back on me. If I push on this wall, it pushes back on me with the exact same force that I push on it. If I push on whatever, if I pull on something, I get that same force pulled back on me or pushed back on me. So, the three laws of motion. A body in constant linear motion tends to stay in motion unless it's acted upon by a force. That's Newton's first law. The second law is F equals ma, that the net external force acting on a body gives it acceleration in that same direction as the force and inversely proportional to its mass. The third law, the action-reaction law. Whatever force I exert on something, or whatever force one body exerts on another, that second body will exert back on the first. So, Newton's three laws of motion. Remember especially what a force is. Again, it's usually just a push or a pull. Yes, there are many other types of forces, but the main thing to remember is it's a push or a pull, and then mass is just how much stuff there are. Force is a vector, mass is a scalar. They're affected by each other. They have a relationship with each other based on force. Or the relationship in the beginning is acceleration is the force, or the mass, or the force is the mass times acceleration. So, back over here, you notice that there are no kinematic equations anymore, but don't forget those, because they're going to play a big part in all this stuff. And remember how to do vectors, because those play a big part in this as well. So, thanks for tuning in, and we'll see you back here for another episode of Physics with Miyoshi.